Okay, so this video is about 6.6. It's rational exponents, so converting between radical form and rational exponent form. Index, exponent, so when you rewrite it from radical form to rational exponent form, you take your exponent divided by your index. An expression with rational exponents simplified is when all the following conditions are met, has no negative exponents, no exponents that are not positive integers to the denominator. It is not a complex fraction, and the index of the remaining radical is the least number possible, meaning you simplify your radicals, or your fractions, excuse me. So, just conversion. When you're converting, the index is 4, so 4th root of 10 to the first, but you don't have to write that first power. 5th root of x. This would be 15 to the 1/3. And then this one would be each one to the 1/4. So 7 exponent is 1 to the 4th. X 6 to the 4. Y 9 to the 4th. 6 to the 4 I can simplify. So this is 7 to the 1/4. X to the 3/2. Y to the 9/4. And that's it. We're done. So evaluating an expression. You can use your calculator if you get exact answers. You need to show your math or you need to show what you're doing, but this is the 3rd root of 343, which means I'm really doing the 3rd root of something cubed, which is 7. The answer is 7, or in my calculator I type it in. Exponents, this would be 1 over 332, to the 1/5, which would give me 1 over the 5th root of 32. Which in my calculator would give me 1/2. Or if I just took 32 to the negative 1/5, I get 1/2. 125 to the 2/3, the 3rd root of 125 squared, or you can pull this exponent out, the 3rd root of 125, and square it that way. Same problem, doesn't matter, because if I rewrote this one here, 125 to the 1/3 squared, multiply those two, I'd get back to here. So the 1/3, or the 3rd root of 125 is 5. So 5 squared, the answer is 25. Last but not least, on this one here, I'm going to simplify the bottom. So this is 4 cubed squared. So if you wanted to, sorry, my nose is running. I would do the square root of 4. This index isn't normally written, but I'm showing that so you understand. The index of 2 is not written, so technically it is not there. It's just the square root cubed. So 2 cubed equals 8. So 24 divided by 8 equals 3. So your answer is 3. On the back side, so if you have the same bases, so these are both the same bases, you just add your exponents. So a to the 3/4 plus 1/2, which gives you a to the 5/4. Done. Division is subtraction, so x to the 4/5 minus 1/5, x to the 3/5. Done. Working on this problem here. So 4th root. 9 can be written as 3 squared, g squared, because you want to write them as exponents because you got to simplify. So then, taking each one to the 4th, 3 to the 2/4, g to the 2/4. So that gives you 3g. They're each to the 1/2. So you can rewrite it as the square root of 3g, or you can have 3g to the 1/2, or you can have each one broken down. On the next one, we're going to rationalize. So, I'm going to first simplify the top. 64 is 32, 2, 16, 2, 16 is 2 to the 4th. So I have 4, 5, 6. So 64 is equal to 2 to the 6. The 5th root. So if I simplified that, I can pull out one group of 5. So that'd be 2 to the 5th root of 2 over the 4th root of 5. Now with this problem, you need to rationalize. I have a better way of rationalizing as I like fractions. So if I write 5 to the 1/4, and this is 2, the 5th root of 2, I need to rationalize this, so I need to make that a total of a 1 as an exponent. So if I have 1/4, I need to add 3 more 5s. So I'm going to have 5 3/4. If I add these two fractions together, because I'm going to multiply, they give me 4/4. So that's 5 to the 4/4. 5 to the 3/4 on top. So this would be 2 the 5th root of 2 times the 4th root of, technically, 125. And this simplifies to be just 5. So my final answer is 2 the 5th root of 2 times the 4th root of 125 over 5. So that's my final answer. Now, coming back over here to C, this has division and excuse me, multiplication at the same time. So with that, if I just write this as one big fraction problem, I would have b cubed c over b to the 1/3 c to the 1/2. So I would do b3 to the minus 1/3, and then c to the 1 minus 1/2. So this comes out to be b to the 8/3 c to the 1/2. On this one here, you got to do a conjugate. So what I like to do is I like to rewrite this as the square root. So the square root of g minus 1, g plus 1. So the conjugate, you got to multiply by the denominator, change the sign. So the square root of g minus 1, square root of g minus 1. And this is from 6/5. Multiply these out. So on the bottom, square the first minus square the second. Square root of g, 1. So that gives me g minus 1 on the bottom. On the top, multiplying it through, square root of g times square root of g is g. Square root of g times the negative 1 is a minus square root of g. I might have did this wrong now that I think about this in the other class. Square root of g times this one is a minus square root of g. Oh, I did do this wrong. That's okay. 1 times 1 is plus 1. So I get g minus 2 square roots of g plus 1. So there's my final answer. It is not 1, and I'm going to have to recheck that out for what I did in my other class. So that's video for 6.6.